Alrighty, these are the solutions to the 2018 Matrices and Probability test. Let's get started on it. Alright, so what we've got here is the typical sort of starting point of matrices type questions. So state the order of matrix B. So this is matrix here, and what we've got is 3 rows and 2 columns. So it is a 3 by 2 matrix. State the value of the element C21. So that is the element that's in matrix C in the second row, first column. This is the second row, this is the first column, so it's -4. Is it possible to find the product matrix AB? Justify your answer. So what we're doing is we're attempting to multiply that by that. So we're attempting to multiply 2 by 2 by a 3 by 2. Now you'll note that these two numbers here are not the same, so matrix multiplication for AB is not defined, but you must state a justification, and the inner two numbers not being the same is not good enough. So you needed to say something like the number of columns in matrix A is not equal to the number of rows in matrix B. Alright, so that had to be stated. Again, that's come up in a further exam in Unit 3-4. So a very similar question to this, and they don't accept inner two numbers are not the same. This line here, or this script here, was also in your notes, and I did emphasize, or I tried to emphasize at the time, that that must be a justification. Okay, so get used to writing that every time you state this answer. Alright, state the order of products matrix AC. So if you recall, A was a 2 by 2, C was a 2 by 3. These, this number here and this number here are what the order of the product matrix is going to be. So AC order is a 2 by 3 matrix. Some of you guys actually went on to multiply the matrices together to work out what it looked like, and then stated that the answer was a 2 by 3. The reality was we could save a bucket load of time and know that just from the orders. Okay, so for this one here, what we needed to do was, we've got a scalar matrix here, so 3b means 3 multiplied by this matrix here. So many of you guys set it up like this: 1/3, 4, -1/2, and 1/4, and then went ahead and multiplied, so that equals 3 over 3, which is 1. 12. 3 lots of -1/2 is -3 on 2. Would prefer the improper fraction there, so if you're thinking about converting that to a mixed number or a decimal, just leave it like that, that's fine. And 3 lots of 3/4 is 3/4. Alright, so over here we needed to add this matrix to this matrix here, recalling that orders have to match perfectly for them to be able to be added. Alright, so here we are going to say that we're going to do 1/2, -3, 6, 3 on 2, plus 1/3, 4, -1/2, and 1/4. Okay, so 1/2 plus 1/3. Well, 1/2 is the same as 3/6, and 1/3 is the same as 2/6, so the answer there is going to be 5/6. -3 plus 4 is 1. 6 plus -1/2 is -5.5. Is 5.5. I prefer the impropers, so 11 on 2 would be my preferred answer, but it was fine if you put 5.5. 5.5 was accepted, so no dramas there. Alright, 3 on 2 plus 1/4 is the same as 6 on 4 plus 1/4, which would be 7 on 4. Okay, so down here, what we wanted to do was determine AB. So when we multiply together, what's the result going to be? Well, first of all, we've got a 2 by 2 and a 2 by 1, so after multiplying, the result will be a 2 by 1 matrix. So what we're going to do is we're going to multiply this element by this element and add this element by this element. So my working out will be -3 times -5 plus 7 times 2, and we're going to also do 2 times negative 5, this element by this element, this element by this element, plus negative 4 times 2. So that's going to equal, what's that, 15 plus 14, and negative 10 plus negative 8, which equals 29 and negative 18. Okay, for this question here, without using any number twice and without using the number 0, write a 2 by 2 matrix which is singular, that is, can't be inversed. Okay, so what we need to note is to inverse a matrix, we're doing AD take BC. Okay, so this is A, B, C, D. And so what has to happen here is AD, when multiplied together and subtracting CB, it's got to equal 0 for it to be singular. Alright, so the condition was that these numbers here had to be different. Okay, so you weren't allowed to use the same number twice. So I looked at numbers that had a good amount of factors. So 12 was one that I thought of that would be good. So if those are 2 and 6, then this would be 4 and 3. AD take BC would be 12 take 12, which is 0. So justify how you know that it doesn't have an inverse. Well, let's inverse it. Okay, so we've got 4, 2, 6, 3, and what we're going to do is, I'm not going to put the equal sign, let's not do that. AD take BC equals 0, and 1 over 0 is not defined, therefore singular. Okay, so down here what we did or needed to do was calculate the determinant of this matrix here. So we're going to multiply these two together, so 0.4 times 0.4, and we're going to subtract these two elements multiplied together. So 0.3 times 0.2. Okay, most of you guys got this out fine. That was 0.16. Subtract, a lot of you wrote down 0.6 here. So you need to understand that we're taking 2/10 of 3/10. Okay, now that's 3/10 times 2/10, which means that that's 6/100 or 0.06. Alright, now when we subtract them, that's going to give us 0.10 or just 0.1. Alright, so now let's inverse it. Okay, so recall that the inverse is 1 over the determinant of the matrix. And then what we do, if you recall, is we swap the position of these two elements here. So D and A go into those spots, and we negate these two elements here, which is the B element and the C element. Alright, so what we're going to do is 1 over 0.1. We're going to swap 0.4 and 0.4, which basically they are the same still. We negate 0.3 and we negate 0.2. Alright, now it's important to note that 1 over 0.1 is simply 10 as a scalar. Okay, and so now what we're going to do is multiply by 10, which means basically shifting the dp on all of those 1 to the right. So we're going to get 4, negative 2, negative 3, and 4. Alright, on to some prob. Okay, so a bag containing 20 balls in total has 9 green, 6 which are red, and we're going to presume 5 others. Alright, so either green or red. Okay, so this is the greens and the reds, which total 15 out of 20, which is the same as 3 on 4. Must simplify those fractions, girls. They will not be kind to you in year 12. You'll lose a mark for that, even though you understand what you're doing. So, cannot afford to lose this one. Simplify your probs. Okay, not red means all the other ones, which are the green ones, which is 9, and the other ones, which is 5. 9 plus 5 is 14 over 20, which is 7 on 10. Alright, this is a corker, this question, and not many of you guys got it right. How many additional red balls must be added to the original bag so the probability of picking a red ball is a half? Alright, so what you noted here was that there's 6 red, and most of you said, well, look, let's just throw 4 more reds, that will make it 10 out of 20, okay? So you said 6 plus 4 equals 10, and that'll make it 10 out of 20 balls. Now the only problem is, in increasing the 4 balls, or the 4 red balls here, what you would need to do is also allow for that in here. So that would be 10 actually out of 24 balls in the bag now, which is not a half, okay? So what we needed to do is actually increase it by 8. Okay, so we're going to go 6 plus 8 over 28, which is 14 over 28, which is a half. So it needed to be an increase of 8 red balls. All right, very difficult one, that one. Alright, so for this one here, in my opinion, even though I'm a massive fan of Venn diagrams, this one was much better to do via the two-way table. Okay, so we could have, or we had 42 students in total, 30 studied chem, 15 physics. So we've got chem or not chem, and physics or not physics in our two-way table. Alright, so what we're going to do is draw up those and add our totals on here. So generally speaking, for a Carnot map or a two-way table, you need a 3x3 grid. Okay, so let's see what information we got given. 30 students studied chemistry. So chemistry down here is 30, and 10 and 15 studied physics. So here's physics over here at 15. 10 of the physics students did not study chemistry. Okay, so that's physics and not chemistry over here. That's that one there, and that is going to equal 10. Alright, so the other thing we know is this one is 42, and now the fun part begins, because what we're going to do is start to make everything equal up. So this must be 5, because 5 plus 10 must total to be 15. This one here must be 25, because 5 and 25 has to equal 30. This one here is going to be, well, let's do this one here, that's an easy calculation. 30 and 12 is 42. That must be 2, that must be 27. So we're presuming that 15 and 27 must equal 42, which it does. Alright, now we're going to do C and P. C and P is this one here, which is 5 on 42. C union P, which means the intersection here, and physics only, and chemistry only. So that's going to be 15 and 25 is 40 out of 42, which simplifies to be 20 out of 21. So almost all of them. You could also remove 2 from 42 rather, which would mean that would be the union, because that's, in Venn diagrams speak, that's removing this part here, which essentially leaves only the union left. Okay, probability of C given P. Okay, so we're doing P. So P has happened. So this is the part that we're focusing in on. And we're saying that what's the chances of C happening given that our total now has shrunk to 15? It's 5 in 15, or a 1 in 3 chance. Alright, so are events C and P independent? So there's a couple of ways you could do this. So what we need to be aware of here is we can use the formula probability of C times probability of P and test whether that's equal to probability of C and P. So that's the independent events check, or you can check to see whether the probability of C given P is equal to the probability of C. Alright, so does knowing P tell us something or change the probabilities? Okay, so in this case here, we've got the C given P, which is 1 in 3, okay, and the probability of C is 30 out of 42, so equals 30 out of 42. which equals, when that's simplified, it will be, oh my goodness, 5 on 7. Okay, so what we can see is 1/3 is not equal to 5 on 7. So let's not equal there. Okay, so this is the test that we're doing. This is the result of the test. When they're not equal, what we say is the events are not independent. Alright, so that's the result of that. You could also do the same thing here, multiply those together and check whether they equal the intersection and say a similar sort of an answer. Alright, this one here was not particularly well done, and I have to admit it was a tricky one. Okay, so there was a few different options that you could use on this one. So what we know is for independent events, the probability of A given B is equal to the probability of A. So let's work out what the probability of A is. And it's going to be 12 on a number, which we don't know, plus 14. Now, why do we know that? Well, it's this number here, so the total amount of elements is going to be x plus this one, plus this one, plus this one. So the total number of elements is whatever's outside here, plus whatever the addition of the elements inside the circles here, okay, the intersection and the A only and B only. And that's what the probability of A is going to be. Alright, now let's go for the probability of A given B. Alright, and that is going to be A given B. So what are the chances of A happening given B has happened? So B has happened, girls. Alright, so that's where we are now. So the chances of A happening, well, there's a 1 in 1 plus 2, 3 chance. Alright, so now what we're going to do is we're being told that they are independent. So this is true here. This one here is going to be true. So let's line them up and let them equal each other. So we're going to say that the probability of, let's not do that. Let's say that 1/3 is equal to, that's A given B is this. So we're going to put that in that spot there. And we're going to put that in that spot there is equal to 12 on x plus 14. Alright, so a couple of ways of doing this. What we can do is, I'm just trying to think of the best way to solve this. Let's cross multiply, but I'll do this nice and slowly here. We're going to multiply this side by x plus 14 and multiply this side by x plus 14. What happens is we get x plus 14 on 3 equals 12. Okay, 3 12s are 36, so x plus 14 equals 36. X equals, take 14, x equals 22. So 22 must be the answer there, okay? And if you had time, which I know a lot of you didn't, you could check your answer very quickly by slamming it into that, or the independent events check, which is probability of A times the probability of B equals probability of A given B. Okay, on to the MC. Alright, I'm just going to pause this video and then bring up. Alright, and now for the multiple choice. So what we're going to do is work through these questions now. So this first question here, it's a no-brainer. Do this one on the calculator. Alright, so we're going to put a 2 by 2 in. That's 7, 9, 2 and 10, and from that we are going to remove this matrix here. Okay, so we're going to remove the 3, 1, 2, 4. So essentially to solve for A we're going to subtract this from both sides. So let's do that first of all. Alright, now what's going to happen is we're going to divide this by 2. So our scalar multiplication is going to be a half. So times that matrix there by 0.5, and let's change this to standard and see what we get. And we get 2403, which is C there. Alright, so this one here was not particularly well done. Whoopsie. Okay, where are we? Calculator, where have you gone? Okay, so this one here, what we're going to do is this matrix here, let's call this matrix A and this matrix B. So we've got AX equals B. What we need to do is get rid of this matrix here to find this unknown matrix. So to do that, we're going to go A inverse multiplied by AX equals. Now we need to pre-multiply here. Okay, so this is a pre-multiply by the inverse matrix here. Okay, so let's go ahead and do that. Just going to flick the always on top. Okay, now what we're going to do is say 2, -3, -1 and 0. We're going to inverse this and multiply it by 8, 6, -4 and 2. And there's our answer over there, which looks to be that one there, is it? Negative, no. That one there. Okay, so the -4 there. So ignore that one there. It's the +4. Okay, over here, most of you guys didn't have any problem with this one. So we're looking at this point here being translated to this point. So as a matrix, it would be 7, 3. Has something done to it, x, y, to give us 2, 2. So what are these values? So this is going to be 9, because -7 plus 9 gives us 2, and this is going to be -1, so the answer was B. Alright, for this one here, not many got this right, and it was a tricky one. Okay, so this one here, what we're noting is we've got a horizontal translation 4 units in the positive direction of the x-axis. Okay, so looking at our horizontal translations here, this is a possibility, this is a possibility, and this is a possibility. Now, because the order in which matrix transformations, or transformations in general, it really does matter, because they want the translation done first, it's got to have something to do with these brackets here. This one is going to do whatever this is first, and then translate last. So that's out. This one here, that doesn't represent a horizontal translation, that's a dilation of some sort. This is also a dilation of some sort. So we're left with 2 contenders now, after simply looking at the first thing. Alright, so followed by reflection in the y-axis. Reflections in the y-axis change the x value. Okay, so what we've got over here is a reflection in the y-axis changing the x value. So which one is it? Well, what you needed to do with this one here is work out the order of this matrix here. This is going to be a 2 by 1, and this is a 2 by 2 matrix. Now you note that here matrix multiplication is not defined. Over here, this is going to be a 2 by 2, and this is a 2 by 1. There we go. Matrix multiplication is defined. That's our winner. Most of you guys went for B on this one. Alright, one letter is chosen at random from the word computer. The probability of the letter being an O, M, or N. O, M, or an N. O, M, or an N. So it looks to be a 2 in 1, 2, 3, 4, 5, 6, 7, 8. 2 in 8, or a 1 in 4 chance. There it is. Alright, a coin is tossed 3 times, landing on heads exactly twice. Look, I was surprised that not many of you drew the tree for this one here. It really does need to get done. So for any multi-stage question, what you want to do is draw that tree up. So head, tail, okay, and note that it's pretty messy, but really you're not doing this to show how aesthetically pleasing your working out is. You're really doing it to actually generate whatever the answer is here. So for this one here, exactly twice means that's out, because that's 3 times. Head, head, tail, that's one of them. Head, tail, head, that's also another one. Head, tail, tail is out. Tail, head, head is in. Tail, head, tail is out. Tail, tail, head is out. Tail, tail, tail is out. So what we've got is 3 matches out of the total of 8 possibilities, 3 in 8 chance. Okay, this one here was a classic addition rule problem. So we've been given the union, the probability of A, and the intersection, and we want the probability of B. So recall that the probability of A plus the probability of B subtract the probability of A intersect B is equal to the probability of A union B. Okay, so this one here, all you needed to be aware of here is that they've given you the union, so you simply rejig the formula or transpose this part to this part. So we're going to use probability of A plus the probability of B, subtract the union, will give us the intersection. So then it was simply a case of whacking the numbers into your calculator or working it out by hand, whichever one you preferred to do. So 0. What have I done here? We want the probability of B, so actually I'm going to have to transpose this even further. So the probability of B is equal to the probability of A intersect B plus the probability of A union B, take away the probability of A. Alright, so I've just noted there that all three of these are exactly the same formula. Don't let anyone tell you that they're different formulas, but we just transpose to find what we're actually after. So what I'm going to do is add the union to the intersection, which is 0.85. The intersection is 0.1, and I'm going to remove the probability of A, which is 0.47. And thanks for the fraction, but I want a decimal, 0.48. Okay, so this one here, you just needed to be aware that for independent events, we've got this situation here. Alright, so what we know is that these two are independent events. For independent events, we know that the probability of A times the probability of B equals the probability of A intersect B. Alright, so if I multiply these two, I get the intersection. So I'm going to do 0.35 times 0.46, and that'll give me the intersection. So over to my calc for that one, 0.35 times 0.46 is 0.161. Alright, now what? Well, what I want is the union, okay? And I've got the intersection now and the probability of A and the probability of B. Brilliant, that's just the addition rule, okay? And it is, which version? I want the union, so it's this version here. All I'm going to do is A plus B take away the intersection. So back over here, I'm going to go 0.35 plus 0.46. Need a decimal point there, 0.46, and I'm going to remove the intersection that I just found, okay, which was 0.161, which gave us 0.649, that one there. Okay, on to the analysis. Okay, so we've got sports company has 2 factories manufacturing different type of exercise equipment. The time spent in hours on different stages is shown here, and so basically if you want to look at it, treadmill takes 7 hours to build, 1 hour to test, half an hour to package. We've also got wage rates at the 2 factories, so building wage rate is going to be $21.50 an hour at factory 1, $21 at factory 2. Alright, state the value of element A23, so here is row 2, column 3, and so you needed to say something very specific here, okay? The number of hours it takes to package a bike. 1. Okay, so you had to multiply, so again with calculator here it was a no-brainer, so A times B 1, 0.5, and oops, I need to add another. Oops, that's good. 6, 1.5, and 1, 8, 1.5, and 0.5. And we're going to multiply that by to get that. So AB equals, for 1 mark, you didn't need to show any working out other than you need to write this. Okay, so for this, it's important to understand what these rows actually represent, okay? So the rows in this case are the equipment, okay? So we've got treadmill, we've got bike, and we've got rowing machine, okay? And the columns in this case represent the factories. This is factory 1 and this is factory 2. Right, so the first row of matrix AB represents, so what we've got is the cost in wages of making a treadmill in factory and the cost in wages of making a treadmill in factory 2. Now it's important to have two separate statements here, or some kind of wording saying respectively, because if you say the cost in wages of making a treadmill in factory 1 and factory 2, you're assuming that factory 1 and factory 2 get added together, that word and, factory 1 and factory 2. Okay, so you need to actually write two separate statements, or say the cost of making a treadmill at factory 1 and factory 2 respectively. Okay, so very important that you treat these as two separate amounts rather than a total. Right, the total cost of producing one treadmill at factory 1, this is treadmill at factory 1, $177.25. Okay, find the total cost of producing one piece of equipment each piece of equipment at factory 2. So the key wording is total cost. So it was the addition of this, this, and this. Okay, so we're going to go 177.25 plus 173.50 plus 207.75. And look, I'd need to do this on the calculator, but I just actually remember the answer. It's $551. Okay, on to the very last problem. It was the probability question. So Sophie travels to work by car and bike or bus on different days. The proportion of time she uses each form is 0.6, 0.25 and 0.15. Okay, so the 0.6 is the car, 0.25 is the bus, this one here, and this one here is the cycle. Okay, so that's event A, event B, and event C. Alright, now let's list this on the tree diagram. So event A is 0.6, 0.25 was event B, and 0.15 is C. Alright, now she's either going to be late for work, in which case she's got a chance of 0.1 when she travels by car, so she's either going to be late or not late. So 0.1, 0.9 is not late. If she travels by car, bus is 0.2, so late or not late, 0.2, 0.8. And finally, cycling is either going to be late or not late, and the prob was 0.45 for late, 0.55 for not late. Okay, So for the first one there, not travelling to work by car, so the chance of her travelling to work by car is 0.6. So it's probability of not travelling to work by car, which is equal to 0.4. Also, the chance of her travelling by bus and what's the other one? And cycling. Okay, so you could have done either. Probability that Sophie travels to work by bus and is on time. Okay, so and means we multiply the two probabilities together. So that's bus and not late. So it's going to be 0.25 times 0.8, which is a quarter of 0.8, which is 0.2. Alright, so the probability that she is going to be late to work. Okay, so we've got three ways of being late. It's this one here, so 0.6 times 0.1. It's this one here, which is 0.25 times 0.1, and the probability of this one here, which is 0.15 times 0.45. So what we're going to do is just write all our working in for this one here. It's going to be the first one, 0.6 times 0.1 plus 0.25 plus 0.2 plus, that should be times 0.15 times 0.45. Alright, so let's see how many of these I can get. This is going to be 0.06. A quarter of 0.2 is 0.05. And I'm not going to risk that last one. So let's get the calc to do that. 0.15 times 0.45. Okay, so 0.0675. Now we've got to add those together, so back to the calc. 0.06 plus 0.05 plus 0.0675, and we get 0.1775. Okay, this last one was a bit tricky. The probability that she travels by car, okay, so travelling by car, you'll recall, is 0.6, so that's that option there, or is on time for work. Okay, so on time for work means, so she travels by car, so that's this one here, or is on time for work. So that's going to be this one here, which is same calculation as that, and 0.15, the same calculation as that one there. So we're going to go 0.6 plus this calculation here, 0.25 times 0.2 plus 0.15 times 0.55. Did I get that right? Yeah, that one. And no, it's not going to be those same calculations. It's going to be those ones there, sorry. So now we need to add these together. 0.6 plus, that's supposed to be 0.8. Okay, so again, to go over that, it's at 0.25, which means that she is on the bus and she's not late or on time. So it's 0.25 times 0.8 plus 0.15 times 0.55. Alright, so that is going to a quarter of that, which is 0.2, and this one here, I'm not going to do that one in my head because I can't do it. Alright, so now I'm just going to get it to tack on 0.2 plus 0.6, which is 0.8. So that will give us 0.8825. Alright, so there's the solutions.